Let's start. For the record, friends, today we are starting our Cosmos Voice number 7, and our guest today is Jakub Gadikian. He is a core contributor of Cosmos. He is kind of Cosmos legend. He is OG. He is founder of Validator Notional. And today our meet called Jakub's Secrets. Of course, this is not really secrets because it's public, it's open source, it's code, and Jakub was writing about it so many times. But for many people, this is still kind of the secret, and they still don't really recognize so many issues and code stuff. But Jakub can explain it with the easy ways. And our host today is Greg, and our guest today is Jakub, and I'm just a person who will help and sometimes asking questions. So friends, let's start Cosmos Voice number 7.
Thank you, Vlad, for the introduction, and also Jakub, thank you for your very first words. We are proud to have you, obviously, in the Cosmos Voice 7. And your time is very much appreciated. So, Jakub, I know a little bit about your past. I try to kind of make my homework a little bit, and I understand a little bit of your journey. For me, as a person who is relatively new to Cosmos, even though we are making a kind of R&D and building a real business project on Cosmos for 3 years. But of course, comparing with people like you who spent so many years on this at that level of detailed contribution, I am newer. Yeah. So I think
like that's how we grow.
So I think that also, for us, people who are running different projects on Cosmos technology, it is actually the content, I think, of this call will be very important. And I hope this will provide some light and help to those projects. And so I am expecting to learn a lot. Now, for those who might, for whatever reason they are new, might not know you yet, just try in a kind of summary, make a summary of your journey. Like before crypto, and then how you get into crypto, and how that journey was. Each of us had like different story.
All right, so. Well, okay, pre-crypto, I was actually a high school teacher. And like I lived in China at that time. I was teaching US history, and China has that firewall, right, that they adjust, and I couldn't contact my family, and I learned that if you bought Bitcoin, you could get a VPN. Now, technically I tried Bitcoin, or that was like 2013 or so. And at that time, like I used it like literally just for the purpose that I bought it for, right? So I bought Bitcoin, tried a VPN, and ended up getting pretty heavily involved with BitShares and then later Steemit. And I guess about 2015 was when I began to like really build in cryptocurrency. And prior to that, was more like I tried to ship a hardware product actually when I left my job. So, I was in Shanghai anyway, and I figured, well, I could just go to Shenzhen and work on a hardware product. At the time, I was collecting Chinese tablet computers, just because you can get all different kinds there, and they're pretty cheap. So I would hack on a bunch of different ones.
Okay, no, that's cool. And please tell us a little bit of how you entered into Cosmos ecosystem, because as far as I understand, you were a contributor of Cosmos at the core level. So tell us a little bit about that part and what made you being interested on Cosmos technology, and then maybe we could jump into like what are the issues, because I think today talk probably is related about some challenges as well about the technology, right? So tell us about this.
Okay, let's break this into two pieces, right? So the first thing is what got me interested, and that was actually like other proof of stake consensus mechanisms and how they work is what got me interested. So before Tendermint got popular, there were at least two major proof of stake products or projects. So the first was called PureCoin, which I never really got involved with, but PureCoin is a Bitcoin fork that added the first proof of stake features. And after PureCoin came BitShares, and BitShares is a really functional exchange product that's actually still running today. So it's a decentralized exchange that I think ultimately kind of boiled down to just like trading shitcoins against each other on BitShares, right? But it had a lot of really novel technical features. It was one of the first oracles. Unfortunately, the product that was supposed to tie to their oracle, that broke, like Luna's oracle, for example. But the same people later released Steemit, and so I became interested in Tendermint because of what I viewed as issues in the consensus mechanism that Steemit was using. And a good example of this is like, so what Cosmos really has, and for sure, like the technical reason that I'm talking to you right now is just that Cosmos has integrated the full finality up and down the stack. So I'll explain full finality real quick, but if you have any questions, let me know. Full finality means that every block is 100% finalized when it's made. Now, I'll explain this because it probably sounds weird. You might be thinking, well, what the hell? Like, how is a block made but not finalized? But actually, pretty much every non-Cosmos chain routinely has what are called reorganizations. These occur. So if this finger here, right, is the tip, the most recent block on Bitcoin, like reorgs are pretty common in the most recent, say, like 3 blocks. They don't happen every block, mind you, right? But they like totally can happen, and that's why exchanges wait like 2 or 3 blocks or sometimes more when you deposit Bitcoin until you can use your funds. And I was fascinated at, just the possibility even of solving that problem. And, I think that my absolute first contact point with the Tendermint project was actually, I learned Go pretty early because I was using Docker in my cloud consulting business. And I was like, what if we could build a blockchain in Go? And I searched GitHub you can filter by language, right? So it was language : Go, and then blockchain. And eventually by doing this, I found, the very, very early Tendermint repository. I think my first commit is something like very silly and trivial, like contribution to the README file or something. And so at that time, Cosmos didn't exist. Like there was no Cosmos SDK, although there was a plan to build all of that stuff. So, my first touch point was like how do we say this?
Pre-Cosmos, pre-Cosmos existence. It was Tendermint, the core of it. Yeah.
Yeah, and pre-fundraiser too. And unfortunately, I didn't participate in the fundraiser, but so stuff was very early back then. And the thing that really got me interested though was full finality, because I felt that would be really important. And then later, another thing that really drew me into Cosmos was IBC. Because I've built chains, not so much contracts, outside of Cosmos, right? So when we built Blurt, which is a Steemit fork, listing it was really hard, right? And so you basically either pay for listings. We were not interested in doing that. Or you basically don't get listed. Blurt is on 2 exchanges now. It's not super well listed. But if Blurt were an IBC chain, right, then it could have just linked up to Osmosis. And it's possible that I'll make Blurt an IBC chain. And actually, maybe this is where we might want to discuss the problems. So, guys, Blurt gets pretty heavy usage compared to most Cosmos chains. And we did Genesis on that about 5 years ago. And I consider Blurt extremely successful, although it has not been the money. I don't know. We kept $1 million market cap the whole time, right? But obviously, it could go way bigger or whatever. But the thing that I'm really satisfied with about it is that even though I'm one of the founders, I don't really touch it anymore. I talked to some people in the community, but really Blurt has achieved a higher level of decentralization than I ever expected. And so when we compare Blurt to a Cosmos chain, what we find is that in Cosmos, we're constantly patching all these little security issues, right? And I think that basically most of these are coming from a lack of definition in the stack. And I think that it's time for us to take all these places in the software stack where we have not tightly defined what can occur. A good example of this, and I can talk about this because it's fixed, okay, is in IBC for about 1.5 years, there were no limitations on the lengths of fields. Now, this might not sound like a big deal, but the chain's not really built to handle a 1 megabyte IBC transaction, right? Or it's not really built to handle a 1 megabyte IBC transaction that also carries a 1 megabyte IBC memo that's also told to travel around IBC using what's called packet forward middleware, right? That's just... It's not in the design spec. And so I think that it's really important now that we refine what kinds of limitations exist for each software module. And also, I think that we really need to test mainnets, because with this set of issues, you can go at testnets. And often the testnet will not fail. The reason for this is that most of the, let's say, really valuable Cosmos chains, they're now pretty old. And I can start a testnet on my computer right now. That's very easy. But it does not have gigabytes of history, right? And all of the mainnets have gigabytes of history, and some of them have terabytes of history. And the reason that this poses an issue is that, teams will write tests that are, they think are authoritative, execute them on their testnet, or sometimes in an automated test framework environment. And then unfortunately, scenarios that are being checked by those tests, they pass anyway. And that's super dangerous because, on mainnet, these scenarios would cause catastrophic failures because the longer that a chain has been operating for and the more transactions it has had, the slower it is, and actually the difference in speed is exponential as growth kicks off. And that is just one of the, let's say, like performance related security issues. And the next thing that I have to say is that all of these things add to each other. So like the fact that IAVL always gets slower over time, that is, the longer the tree is, the slower searching the tree is. It creates a situation where most mainnets are really, really different from most testnets. And then the next aspect of, mainnet versus testnet and why working on them is so different is size in terms of nodes. Most mainnets, the big ones, right? So let's say like a Luna or a Cosmos Hub or an Osmosis, typically run around somewhere between 2,500 and 5,000 nodes. And that, that's for the mainnet. But the testnet, many of these only have like 30 or 40 nodes. So if you can break a testnet that has 30 or 40 nodes, can you imagine what you can do to a mainnet? And then in some of the situations, so really what Meteorite does, Meteorite is a product that I built with Joe Bowman from Quicksilver under the Somatic Labs name. And that might be like Next Company or something. I don't really know, but there's a GitHub repository, Somatic Labs, and there's a name. But what Meteorite does is it makes it really easy for end users to actually test if a chain lives up to the performance claims that are being made about it. Now, the reason that this is an issue, and I guess I'll go real deep here, and then if people have questions or whatever, you can jump in. The reason this is an issue is, guys, this is what took out Luna. Like, Luna was assassinated. It was shot. It was hacked. And it's incredibly clear. I'll link to a doc on this. But basically, like, my one document that I'll throw in the chat, right, is, I don't know, not that big a deal. But the problem is that I ended up being right. And this doc was written basically like as I was watching Luna go down. And so there are a couple of things in it that like maybe didn't need to be included or whatever, but I ended up being like way more right than I ever thought that I could be about why Luna went down. So basically somebody, I can show you the address, I can show you the transactions, intentionally did a combination of contract migrate and contract executions really fast that that absolutely took out the chain. Now, the other thing, I keep saying took out the chain. Well, what does it mean? It means the chain doesn't make blocks. And the most devastating thing that happened with Luna was that every time the attacker made it not make blocks, and during the death cycle, the longest like not making blocks time was 20 minutes. It's supposed to make one every 6 seconds. Okay. Every time that happened, the prices in Luna's Oracle would further diverge from like the prices on the chain. And that gets to be, really serious because that Oracle represented very serious money. You can also find that the attacker likely knew that they could monopolize the chain. So the attacker was able to liquidate, I don't know, probably thousands of anchor positions, maybe hundreds of thousands. I don't know how many there were, but he caught tons and tons of these liquidations. And, you could actually see users tweeting that they could not use the chain. And the reason they couldn't use the chain is that this guy was, causing it to be non-operational. Now, maybe the other thing to mention here, and I think this is very important to mention, is that this issue class, when I saw it take out Luna, well, that was the second time I had seen it. The first time that I saw it was actually on Sentinel in fall of 2021. And what it looked like there was there were these client update transactions that would just bounce around, and anytime these client update transactions were present, the chain would miss blocks. I didn't figure out till literally years later that that these two things were actually like the same problem. You were basically seeing like different effects of the exact same problem. And unfortunately, again, let's just blame me. Let's say like, I don't know, Jacob's a terrible communicator or whatever. Despite like, guys, if you just like, I'll link to the Meteorite repository too. My 5-year-old can use this software, has used this software, and you can too. You just make a file called seed phrase, put a seed phrase in it, make sure the wallet is funded, and Meteorite is actually pre-configured for most major Cosmos chains. If you get it configured correctly, guys, I must say, like, Meteorite can be like pretty devastating, and I did not build it so that like people can just go and take out mainnets. I built it so that people could actually like evaluate the performance of mainnets. But I do want to say that like the main branch is intentionally weakened. It's a lot slower than it could be. It can be about 100 times faster. I don't think any Cosmos network like survives that, with the exception of Thor and FET. And there's a reason for that. Thor and FET both did very major engineering efforts to make sure that this wasn't a problem for them. On the Thor chain side, it's just they have very high fees. It's like $1 to make a TX. And since it's like $1 to make a TX on Thor chain, you don't really need to worry about it going down. Like, because an attacker, if you wanted to take out Thor chain, and I had this conversation with their security team, I thought they did so well with it. They were like, yeah, actually, we have that problem. We made the transaction fees $1 because of that problem. And I was like, hell yeah. Because it doesn't really solve it, right? But it's going to dramatically reduce the likelihood that somebody's going to go and hack you, because it's just going to be expensive to do. Although hack is kind of the wrong word here, guys. Another thing to stress about Meteorite is like, it's got no magic. All it does is it uses the chain like any user and makes a lot of transactions quickly. If that's all it takes to basically turn these chains off, that's a very major problem. So, I don't know, to their credit, right? Interchain Labs like actually recognized one of these issues that's called bank storms. Okay. And there was a fix relatively quickly, but unfortunately, what we're not seeing is the kind of like sustained research that would be necessary to actually like, guys, the bank module I tested it first because I thought it would be very unlikely to have a problem because it's well audited and really performant. Like the bank module is very fast. So I actually expected to make no finding when I tested bank. And the reason I haven't written the other modules, every module other than bank is much more complicated than bank. Bank is like simple. I love the design. It's very fast. And so I also knew, just because like basically in the SDK, we turn what you're doing on the chain into an automatically computed gas value, right? And I knew that if bank was broken like this, then everything is. And you can only say this stuff for so long, and you can only say this stuff so many times until like it just really looks like, I don't know, people are aware of this but don't care, or maybe don't understand it. But what I do want to tell the community is that like Meteorite, it works. You can send transactions very, very quickly. And unfortunately, what you're also going to find, as soon as you have sent those transactions, you're going to find that high load causes serious instability.
Cool. No, that's all extremely interesting. And by the way, please notice that even me, when I am hearing all these stories about challenges in security, of course, I am concerned as as a person who is involved in real business, which is running on Cosmos. Now, so this is very much appreciated. Now, having said that, I wanted to ask you a couple of things, or maybe kind of add like extra light. As you were speaking, I was making some notes, and I realized a few aspects. So these potential risks in security are actually impacting potentially different projects in different way. And let me give you an example. For you, it will be very, very easy to kind of understand where I'm coming from. Comparing, let's say, a large chain like Uniswap with thousands of nodes, as you mentioned, which is a chain that is decentralized and has a kind of little control on what is happening in terms of validators that they have because of the size of the chain. Comparing this situation with like a very small, relatively small chain, which is maybe running only 30 validators or 50 validators, which could be, by the way, perfectly sufficient, for the business. Maybe it is not like a huge chain, but still for the size of the business, maybe these 50 validators are, very much okay, for what they need. Now, another different element would be, okay, is this risk related to the fact that the chain is permissionless? Or for chain that are permissioned, that risk is lowering substantially, let's say. So could you speak a little bit about these different circumstances? And especially, I think it could be interesting to say a little bit more about these smaller chains as well. I know where you were coming from, but tell us a little bit about that situation of smaller projects.
Okay. So actually, may I just ask which chain you work on?
Yeah, so we have a very humble project. It's called DAODISEO. What is interesting in our project that we started with real-world assets that we own. So we own smart village development in Greece. So is asset that is existing, and we are always kind of joking that the seriousness comes from the fact that it's fully paid. So this real world asset is, I call it, pristine asset, because there is no mortgage against this, there is no any charge against this. So for project like us, what we want is, the blockchain as a database where we can actually recognize all the transactions related with the development process of real estate assets. So basically, in that world of engineering, people are speaking about something called digital twin. Digital twin is basically like a twin, like a copy of the real asset. So if you have a villa, so let's say you have information about the villa, and that is stored in something called building information model database. And what we want is to track everything that is happening on that business information model via blockchain. So for us, like now we have a testnet with 50 validators, and we believe that, that size is very much appropriate for us, and maybe even for the mainnet. Yeah. So that would be the case, real case that you have. So I would very much appreciate if you tell us a little bit about the risks that we have.
Absolutely. So, all right. I mean, the biggest one is that I believe strongly that anybody who tried to could probably stop your chain. And if you'd like, I can try. It comes right back up. But the people can stop it. And so, like with Luna, the reason that was a problem, right? Because with many chains, you stop it, there's no problem. When you get to having an oracle, though, that's no longer the case. So Luna was liveness sensitive because its oracle couldn't really handle downtime. I got to say, I've always felt that Skip did a really, really good job with sort of like cleaning up the Cosmos Oracle scene with their Connect product, which it's like the first implementation of, what is that Comet feature called? The informal vote extensions. It's the first like, live implementation of vote extensions that worked. And so like, it would be hard for us to have a problem that's as severe as what happened to Luna, because we don't have any, well, to my knowledge, we don't have any vulnerable oracles anymore. Except, of course, like for the Oracle on Luna Classic, but that's no longer in use, thank God. And so, for you, right, you'd be looking at like a loss of liveness leading to, well, your platform would go down, right, because users couldn't transact. And then from like the hacking angle, there's also something pretty worrying. So one person with only like a small internet line, right, can take your chain down, and then they can become the only person who can get transactions through. And there are a bunch of different like techniques for that. But basically, like once you have begun to overwhelm the network, you become effectively like its owner. Now, what I mean by like its owner is that you, as somebody who is very carefully flooding the mempool, and then also flooding what's called block gossip, and then getting those to actually compete with each other bandwidth wise. So that's how peer-to-peer storms works, is you get different components of Comet to actually chew up so much bandwidth that validators can no longer make blocks. And unfortunately, that's very reliable. And I can walk you through too some things that I have not tested, but I strongly suspect would take out chains. So like if you did, say, 100,000 vesting accounts all at once, oh yeah, they're not performance optimized, right? Like Bank is fast. So I did not expect to find bank storms at all. Bank is very minimal. It's very clean code. It's, if you're going to write a Cosmos module, right, have a look at Bank. It's really well done. I tested it because I figured I would find no problems. And unfortunately, that just wasn't the case. So And now here's the assumption. Since I have not tested governance, I have not tested vesting, I've not tested, there are a bunch of modules with transactions that you can make that I haven't yet tested, and all of them, every single one, is more complicated than bank, but you can take out chains with just bank send. Seriously, you can actually make the chain stop just using bank send transactions. That's an issue. And then with traded assets, right? So you mentioned that these are, you're trading houses on this thing. Well, if one person can make all the transactions and prevent others from transacting and maybe prevent it from, making blocks, there's another big issue, which is that actually they can distort prices. And that was the goal of the Luna attacker. They absolutely wanted to cause a multi-billion-dollar shit show. And I mean, the trouble is that I do understand how they did that. And I believe strongly that but it's not just I believe strongly too. So I did this on testnets at first, right? And I don't know, much to my surprise, even though I had replicated pretty clearly exactly what took out Luna, people were like, so what? The chain stops. And I want to let everybody know I do understand that point of view, right? But if we're not okay, the comment team then responded to this by basically saying, okay, we don't make any guarantees about block time. All right, that's true, and it's an improvement, right? But I mean, at the same time, what we're not saying is a few thousand of the right type of transaction will allow anybody to choose the block time. Because also Meteorite, once you get a response from using Meteorite, and what a response looks like, okay, is you'll start to see that validators are not making blocks as they should. So in the ping pub view, right, they'll show up red. If you take out its 1/3 of vote power, right, then the chain stops, and that's a safety feature, and that's a good thing. But why can't validators handle more transactions? Well, and this is why it's you don't really want to test it on a testnet. So on a testnet, validators set up a really, really different configuration. Typically fewer security measures, and you know what? That's fine. It's a testnet. You don't need to bring your full mainnet battle gear in, right? There's a huge cost difference there. Some people do deploy in exactly the same way between mainnet and testnet. And by the way, I think that's good. That's the way to do things, but not everybody's going to, and certainly not everybody should need to. And then certainly this shouldn't be the reason for that, right? We shouldn't be building all of these, most of the testnets are kind of pointless, actually. And because if we're not testing load as, let's say, a potential issue, what we're actually doing is turning a blind eye to something that anybody who's checked can see has been exploited probably more than once. Because there was Range Security did a report on it. There was an incident on Osmosis too, about 1.4 million.
Jakub, may I just interrupt you for the moment? Something came to my mind now. And let me give you a little bit of background why I am saying this and where I am coming from. In my I would say traditional non-crypto life, basically, I am doing IT deployment as well, and typically we are doing this for large corporations we are implementing so-called ERP systems. Yeah. So of course we have a similar situation where we have like a different environments. So we have, let's say, development environment, and then quality test environment, and then production environment, and software, of course, like go through all these environments and to make sure that whatever go to production is actually first exactly the same what was on the previous environments. And then also, avoiding the risks of consolidation with existing software, which is running, potentially impacting operations all around the world, for different companies, right? So this is like a kind of best practices and the excellence of, those companies when it comes to, let's say, deploying the systems and, re-engineering the systems and then maintaining them. Would you be so kind and explain a little bit, what would be the reason? Because, my kind of common sense and this traditional experience is, of course, pushing me into situation where my testnet would be exactly the same as the mainnet. I'm not imagining this almost like, in being in different way. So whatever we are doing in the testnet, we are taking then this to the mainnet, but assuming that your testnet is still a valid environment for keep developing and keep adding functionality in order to be able to kind of move new stuff to production. Yeah. So tell me a little bit about this. Am I kind of in the right track? Is this still like the best practice in crypto? Am I avoiding possible troubles because of that? And also things that you mentioned, like higher fees. So let's say that we are in the chain that has, smaller number of transactions, which is very reasonable, especially at the beginning. You might actually have, like a bigger amount of transaction, like a amount of money involved in the transaction could be big, but the number of transactions is relatively small. Yeah. So let's say chains like these could, as you suggested, one of the chain increasing fees for transaction because, the chain would still support it, even the transaction is expensive. Yeah. So are those ideas that I kind of mentioned helping to prevent the problems? And also, is there anything that we could do, right, to protect our chains? Like, very important thing, of course, as someone who is promoting the project, I would not like to see my chain stopped, even though probably we could cope with that, as you rightly said, because probably for the smaller project, if the solution is not working, let's say X amount of time, and then you put it back, probably, you will be still okay. You will be able still to recover, but of course you will have a credibility issue, right? So your credibility will be damaged. Your image will be damaged, right? So tell us a little bit about these potential preventions and, if the best practices are helping. Yeah.
Yeah. So, all right, in the beginning, you started off with the differences between testnet and mainnet, and I just want to say that you're definitely following like the correct software development practice, right? Like, so do have a testnet and do move features from testnet to mainnet. The thing that you might want to also do to reduce risk is routinely load test your mainnet. Now, I don't know if you guys use Cosmos WASM, but so in the Interchain Berlin chat, Interchain Summit Berlin chat, right? I was going on about some of this stuff, and keep in mind that with these performance issues, right? Because these are performance issues that then impact security. They're not all natively security issues, but there are also some like just plain old-fashioned security issues. And these things like really blend together here. Solution, test your mainnet, right? Like beat the hell out of it. Know the differences in topology, so like the shape of the network, between testnet and mainnet, if there are any, right? And then I just want to say that, like, when it comes to code, no, you're totally right. You want to go, code moves from testnet to mainnet. And I guess the thing that most chains are likely missing is sort of like just a rigorous and routine practice of actually performing tests against live mainnets. Like a really good example of this, okay? I've done it, so I know. Unless stuff has been fixed, if you just take Meteorite, configure the WASM module, and so Meteorite is just a fast transaction sender, right? So you can link that up to any contract on your chain, and you can test, okay, how many transactions per second can I do on this one individual contract, right? The chain will stop. Like, how certain am I is almost 100%? I haven't seen one that doesn't. I've tested a lot of chains. And I don't know why that's not an issue. It doesn't make any sense to me.
Jakob, just to take this part, so if I understood you correctly, and please, forgive me for my ignorance and lack of experience, and maybe my question might be stupid, but is this risk still related to potential high volume of transactions provoked by someone in the kind of malicious way? So if you make it expensive, in a sense, you are protecting yourself. Am I correct?
Yeah, I definitely agree with that. I mean, like, if you look at Thorchain had the same problem that everybody else did, right? It's just that on Thorchain, every TX cost $1. There was, there are some Cosmos chains where, like, you can do a transaction for much, much less than a penny. And that's all well and good as long as, transaction volume can't make the chain just fall over. But unfortunately, that turned out to be the case. And then also, you really don't want the chain to grow too fast. So, like, I think that we didn't plan too well for, like, Cosmos growth. And so the size of the chain on disk grows really pretty fast. Mm-hmm. And there's likely some stuff that we could do about that. And I think that we probably should. But of course, and this, again, this is nobody's fault. A lot of people think that, like, I'm blaming them for the issues. And no. It's complicated software. Like, nobody's to blame. Tendermint, I think, has literally hundreds of contributors. I think that's true of the SDK. I think that might be true of IBC. So, like, these are pretty big, mature modules where it's not like you can't just point at any one org and be like, oh, this is your fault, right? It's a systemic issue. And so my opinion is we really need to have a look at the stack in a holistic way. And when I say holistic, I mean, like, yeah, you should look at your chain code, but also we need to look at the SDK. We need to look at IBC. We need to look at Comet, and we need to figure out the places in the interplay between these things. And this is where it gets really complicated because these are independent and mature repositories that, like, really do have some issues working together. But they were maintained for a very long time by separate teams. And, like, so they sort of developed this worldview of, like, even though I'm not aware of a single chain that uses IBC Go but isn't a Cosmos chain, right? But we don't really think about these as integrated, libraries. IBC Go has this ambition to be like a generic, let's say, generic bridge, generic secure bridge, for lack of, better terms. when really it's, just a key part of the Cosmos stack and probably should just be a part of the Cosmos SDK. And the reason that I'm saying that is that there have been many half-year or more long instances where actually development on IBC kind of pauses because the main task is upgrading IBC to the next version of the SDK. And then when you have IBC and the SDK upgraded, you can finally upgrade Cosmos WASM. And this causes us like really long release cycles, and we really, no other way to say it, like we waste a lot of time on it. So I think that accelerating development through process improvement is very important to Cosmos at this point. Like some of these, where I talk about like it's both a security issue and a performance issue, or maybe more accurately, it's a performance issue whose second order effects, also include security if you include liveness as a security issue. And I don't know, I do consider liveness to be a security issue. So stuff you can do, the number one thing that you can do to protect your network is definitely to test it. What I can say is that like I'm not even satisfied with the state of the test tools though. And yeah, they're my own test tools. It's just like, there's definitely no funding for Meteorite. And so that limits the amount of time that I can spend on it. And so like, if I did have more time to spend on it, I would implement all of the modules. I would probably like, and it's a touchy thing that I did actually check with like, various legal people, right? Because some people were like, you're hacking these chains. And you know what? Like they have a point, right? But the thing is that you're paying for every transaction. And so like basically what I learned is under the law, provided that you are paying for your transactions and you're not like stealing from somebody, it's fine. But then there are situations like some people have said that peer-to-peer storms is a DDoS attack, which is funny because it's opposite a DDoS. You actually like, you're sending tiny amounts of data into the network, and then there's an amplification. And that amplification is basically like the nodes spamming one another to death. And so I guess why I'm saying this is that I really do not believe that any of these issues have been solved. I challenge anybody in the audience to be really fun. You should try it.
Jacob, something that came to my mind now. Please treat it a little bit as a fun or joke or anecdote. But it came to my mind that it is better to have you on our side. So it's better to be a friend of you in this sense for any project. But yeah, I very much appreciate what you are saying. Like coming back a little bit to our example, because you asked if we are Cosmos WASM. So yes, we are Cosmos WASM. For the reasons that probably are obvious for you, we are actually permissioned. So we selected a number of addresses.
There is a big difference. Unfortunately, for like this particular thing, it doesn't matter that you're permissioned, but overall, like look, guys, if you want to like get a nice idea of what good engineering choices in Cosmos look like, you just look at the Osmosis repository. Osmosis is definitely not a perfect chain, definitely not a perfect team, but you know what? They do damn good, and it's pretty consistent. So I would say like they're pretty good to look at for like best practices in terms of like how to structure your code and stuff like that. Yeah.
And Jacob,
permission.
Do you maybe have some words? I know that referring to the project sometimes is not easy, of course, but DAODAO. So DAODAO as a project, DAODAO as as a user interface governance platform that is actually using Cosmos WASM, and therefore definitely, quite complex code that with a lot of functionality that is there. And actually, DAODISEO is an example of project that will be adopting, DAODAO as our interface for governance. So what do you think, about that? And what is there anything that you would like to say?
Yeah, so DAODAO kicks ass. And actually, I was thinking about using it in one of my own projects coming up. The weakness that you're going to find, right, is that, so you sound like you're actually quite experienced with the stack. So I'll give you a couple of scenarios that like you might not have tried, but if you try them, your chain is going to stop, like almost certain. So take one of the contracts, it's already deployed on your chain, right? And then scaffold out a contract execute transaction, right? And then just make a bash loop. Okay, like no joke, just like an infinite bash loop, right? So while true, do, and then stick that like CLI TX in there. You'll stop your chain. That's how easy it is. And like it's somewhere around like 300 TX in a block, but it may be less. And but the reason that I'm mentioning this, right, is that actually this is a place where you probably can make your chain a lot more stable. So once we start to actually dig into, okay, how much TX volume can this contract actually take? Let's just say it's like your instance of DAODAO, right? So, okay, how much TX volume can we do on your particular instance of DAODAO, and then where do those failures come from? The WASM module of Meteorite is like a little half done for this. So what you would do is actually customize Meteorite to call exactly your module. And keep in mind that you don't have to have like just one call. Meteorite is dynamic, so you can call whatever you want. And you can mix the calls too, which actually is a little important, because one of the things that I've learned is like, if you combine certain transactions, you get extra help. And, the chain will allow whatever into the block. Another thing that's likely to cause hell, do repeated contract migrations or repeated contract initializations. Do contract executions with zero gas. Yeah, it'll execute. Oh, yeah. It just does.
Yeah. So, what I am seeing, from my perception of a little bit like how you are communicating all these. Do you think it's almost mandatory, or definitely very recommended to almost get I would say support of someone who is dedicated to that. Of course, we have these audit companies. I don't know if the audit companies in all cases are doing a proper job. That's another thing. But it is almost like a combination of this audit and someone who is extremely knowledgeable about vulnerabilities of the Cosmos ecosystem. Yeah, I would say that is almost like a business on its own. After this conversation, I at some point I will be thinking to get Jakob like Jakob supporting our chain in some sense, because definitely there is a value out of it, and maybe we need to pay. Yeah, so don't get me wrong, but I am just
that is actually like kind of the Meteorite business plan, or like part of it. And if you'd like, I'm happy to set that kind of thing up. And I guess what I would say certainly doesn't like necessarily need to be me. I'm happy to do it. But my point is that like the reason that Meteorite is there, open source, is that what I noticed is that unfortunately, I don't know if it's the ICF or like what or who. And again, this is not a blame conversation, right? But like, it just, we're not very responsive to like this class of issues. So I built tools that, you know, would let anybody sort of find their results basically by taking chains down. So like the last time that I used Meteorite seriously was a test network. I was tutoring a firm called LimeChain. Those guys are like really, really awesome, and they had me out there to sort of like run through these issues and other like common risks in Cosmos development. And we put up a little test network on Raspberry Pis and then like very quickly took it out. The reason the Raspberry Pi is kind of interesting as, let's say, a platform for running these tests is that the Raspberry Pi is like very strictly defined hardware, right? But when you look at a real world network, right, you don't actually have that. So you don't really know to what degree is hardware performance, you know, limiting the chain's ability to make blocks. I have a theory that it's not all that hardware driven, but that bandwidth matters a lot. So like validators should probably start looking to get lines that are over 1 gigabit a second, because when you saturate that gigabit, a lot of networks just die because most of the validators are on 1 gigabit lines, right? So that's kind of like an easy hardware related point. And the other pretty clear hardware finding is that your hard drive performance, it matters like way more than you think on a validator. So like when you have a slow drive, it's much easier to kind of cause the node to go into a tailspin. And I did that actually by running fast and slow drives on Notional validators, trying to figure out how to, I don't know if you remember that time when like Osmosis would stop every day at the same time. I was just sort of testing out that problem, and it turned out to be almost entirely hard drives. The faster a validator's hard drive would be, the quicker that they could make that next block. And that ended up being like mainly database iterator performance. So when we studied that, like we were able to actually make some changes that made that less likely to happen. Probably the biggest one is PebbleDB. I think that when Pebble is finally rolled out across many chains, like we'll see a pretty big boost in Cosmos performance.
Yeah, no, thank you. I must say that amount of elements that I learned today is amazing. Of course, I am a little bit disturbed, let me say, as someone who is co-leading a serious project with the serious business. So I am a little bit concerned about that. I am also kind of learning some guidelines that might definitely help. I think I am also understanding now much better how important it is a proper validator infrastructure. So especially in the mainnet, having quality validators who are actually running proven infrastructure with kind of improved hardware, good disk qualities, and maybe higher specs for your server, probably might impact positively and reduce the risks.
It definitely does. You want me to give like a quick guide, just to anybody in the audience who's validating the spec that I consider to be approximately ideal. So basically, you want like more or less the fastest RAM you can get, but I do not recommend ECC RAM. So literally just like cheap gaming PC RAM is really good, actually. And for the hard drive, go crazy. Like, get an M5, or sorry, PCIe 5.0 M2 SSD. And the reason for that is that it's really surprising the difference it makes. Certain scenarios, like over 100x, our node on Osmosis. So right now, Notional is not operating any validators, but like when we did, our node would make that long block in about 30 seconds when others were taking like 20 to 30 minutes. And really, that was all hard drive optimizations. I think at that time, like when that was a problem, we might have also been doing like RAID 0, which just everybody please know that RAID 0 does not keep a backup. It's all speed. So, just be careful, right? Or even do RAID 0.1, which gets you both a backup and the extra speed.
That's definitely is like kind of extra hints that are important. I wanted to ask you one more thing that you mentioned at some point of our conversation, but I didn't want it to kind of interrupt at that point in time. You mentioned about like a exponential growth of the database with time, which especially become a problem for large chains which are running mainnets for years. Now let me ask you maybe, I hope not that stupid question.
No stupid questions exist.
in typically in the kind of real business, let's say I want to come back again to compare this with the kind of traditional world. When the company is running the databases, imagine in all the countries around the world, all these legal entities running all the operations, thousands of orders of different type, like hundreds of thousands of documents like created every year. And of course, this information is also accumulating and is all hosted typically in the same systems. So at some point they also have like that difficulty of, okay, what we are going to do, because we are not going to handle all these database necessarily. We don't need it even to be accessible immediately, because our like relevant information for our operation maybe is actually for like 2 years, for the last 2 years, and the rest is actually archived and could be accessed, of course, but not necessarily immediately, which might not be even necessary, right? So can you tell me something about this, like how this, I would say, metaphor from the traditional world would be applied in the world of blockchain, which at the end is another database?
Totally. So actually, the first thing is that where a database is going to have like some kind of fixed set of performance characteristics, right? And if it's just on one machine, then you can really know how that database is going to perform. But a blockchain is multiple computers that are basically serving as your database, and you don't control the links between those computers. You really don't know. And actually, that was part of the reason behind Meteorite, was just like, hey, what does happen when we send lots of, I think that at first it was oversized IBC transactions. That was my first replication of the peer-to-peer storms issue, but that branched out into some other things also. And so if we're just looking at like comparing to like a typical database, then what I would say is that only testing your mainnet is actually going to give you the sort of numbers that you need to reliably know how your network is going to work. which I guess is why, I'm kind of coming out here and I'm just saying, like, guys, we should not rely on testnets anymore for testing load specifically, just because there's so many reasons they don't really work for that. You mentioned for a second, like, just the fact that there's that exponential slowdown, and I'll explain that real quick. So that actually comes from this thing called IAVL, which we use these immutable AVL trees, and I'll grab the repository for you. And what this does, so IAVL automatically hashes the state of each Cosmos module, each block, and then these are summarized into, it's called the app hash, but it might not be the app hash, I think, is a summary of each module, but if it's not that, then the block hash is. We basically like combine all these hashes to get our final values. And the reason that IAVL slows down over time is that the more content there is in the chain, the more work there is for it to do. And so this is like, IAVL is one part of the problem. And actually, to maybe like drive home on solutions, I have absolutely no idea why IAVL is not a part of the Cosmos SDK repository. It's a very, very important part of like what Cosmos is. And it's kind of like kept off to the side in this IAVL repo. And let's see, where was Dragonberry? Dragonberry was in ICS 23. And so like, this is where Dragonberry lived. Well, it lived in several places, but it definitely lived right here. And ICS 23 interacts with IAVL on some levels. And basically, like, they should probably just all go in the same repository. But we split everything out. And what that means is that the Cosmos code base is currently difficult to manage, right? Because at one point, even the Cosmos Hub was actually this thing called Basecoin. And Basecoin was actually like, that was the Cosmos SDK for a while. My fork of the Cosmos SDK is actually called Basecoin because the Basecoin repository was eventually renamed to Cosmos SDK. And I just never updated the name of my fork. And I guess what I'm trying to say is that reducing the number of independent repositories could make it much easier for us to actually test the code, monitor the state of the code, and integrate new pieces of code. And I think that testing really is like the most important thing. I've never really been able to figure out why nobody else like really tried to test. I know I should give some props though, because one team did. It's Mustache Greg. What's the name of his project again? Dean Tribble, and he works on Agoric, and he's not even named Greg. He's Dean. Anyway, so their chain actually has tested with Meteorite, and the validators told me they actually learned a lot. So that's pretty cool.
Yeah, no, that's definitely amazing, and I truly believe that more attention should be put on this area, and I really hope that through your activities and awareness, you will get deserve attention from the Cosmos ecosystem as a whole to treat actually these topics very seriously. Something that definitely sound terribly important. Again, when I think about traditional world and, hearing something like what you just explained today, of course, would concern, anyone that is running such piece of technology and knowing that maybe there is a high value stored on that database, and things could go wrong, which none of us wants, but we know that these risks definitely are out there. So thanks a lot for that.
Thank you. Thank you very much.
Look, I think we need to give at least an opportunity if there is anyone that wants to say something or have some question that we would like not to be missed today. It's 8:20 now, so I think let's ask if there is anyone who has a question that needs to be responded. Please.
Friends, of course, I have some small question. So, what's about solutions? If we know what's wrong, how we can fix it? Yes, is it fixable or not? Yes, do we need to create new SDK, or just we can fix some parts? And the second question, Greg has already mentioned, this is the very good use case for the providing services of the fixing such problems, and maybe it even can be kind of the business, something like connected to audit and so on. So what's your thoughts on making it better?
Yeah, so all right. There's not going to be like a universal fix. Actually, for Cosmos WASM, there is a universal fix. For Cosmos WASM, we need to just get much more strict about, well, everything. In Cosmos WASM, there's a lot of stuff that isn't like super well defined. And one of the things that isn't super well defined is actually the virtual machine interface. There is only like, you can derive a definition of the virtual machine interface, but there's not really like a strict set of like exactly what the contract virtual machine should be able to do. Good example of this, a lot of fields don't have limitations. And that was, that was a classic in IBC. Like, you used to be able to make 10 megabyte IBC packets, and unfortunately it got reported for about a year and a half. Absolutely nothing got fixed, and I had to publicly disclose the issue on the IBC Go repository, explaining to the whole freaking world that you can make 10 megabyte IBC packets and that's not good. And then it got fixed. And so, like, one thing that I'm definitely trying to get to happen, but I've not seen progress on, right, is like, do reported issues actually get triaged and dealt with deeply? Okay, so if we look at the most recent one, that was bank storms, but there's also, some stuff that I've reported to Mag and Barry that I don't know, I just, don't get any reply on. But bank storms, they did recognize, but unfortunately they did not go through every other module and test them. Because like I said, bank is the simplest one. Bank is the fastest one. Bank is the one where you're least likely to have problems. That's why I tested it first. If you wanted to like make findings, right, you would look at like the governance module. It's pretty complex, right? And so the more complex the transaction is, the more likely that just looping that same transaction is going to take out the chain. And then, I don't know, a lot of people like to say, well, like, hey, these sound like really simple issues. It's like not that big a deal. And I'm like, well, how big of a deal is it if your chain makes blocks? Because I get it. Like, okay, it just stops. There's like not really theft, but then at the same time, like when it's making blocks, it exists. When it doesn't make blocks, it also doesn't really exist. To go to solutions real quick. Okay, so Vladdy, check it out. For Cosmos WASM, the solution is like formalization and just sort of drilling down. It's like, what should a contract really be able to do, and where do we enforce the rules? Personally, I'm a fan of enforce the rules everywhere. I can link to several recent Cosmos WASM fixes that my reports have caused to get fixed. And I will say that, I reported these things privately, but needed to raise them publicly to get them fixed. And that's not cool. Because that also like puts me in a very uncomfortable position. I do not want to like be the guy who has to come out and be like, yo, that like, not only is it broke, but like you tell them it's broke repeatedly and they just get angry at you. I'm not doing any of this stuff to like anger anybody. It's just, if I'm going to go and I'm going to promote the toolkit and I'm going to be like, hey, everybody grab $1 billion and put it into, Cosmos infrastructure, right? Well, then I really want to know that the infrastructure is going to hold up when it's got $1 billion on it. Because I can tell everybody here why there's not been another Luna attack. We haven't had another $100 billion chain. The minute that we had another $100 billion chain, we would have something to suck $100 billion from. And people will try. I don't know, like we have to expect that. We can't expect that like people are like just going to be nice to our chains, right? Like what we should actually expect is that as soon as there's something valuable to take, people are going to try really freaking hard to take it. And unfortunately right now, our security model is sort of like, well, you should just be nice to the chain. And I don't know, whoever took out Luna, they were not very nice to that chain. So I don't think we should rely on people to be nice to the chains. Oh, sorry, I keep going through fixes. I apologize. So Cosmos WASM has a very clear fix of just like tightening everything. For IBC, it's similar plus testing. Okay, so when I speak of IBC here, think of IBC as like just another Cosmos SDK module. Now, most engineers in Cosmos do not think of IBC that way. And it's because it was removed from the SDK, and also IBC is multiple modules. But if we instead just think like, okay, you should individually test each module and each contract to learn their performance characteristics, to learn if a given module can take down your chain or a given contract. How do I explain this? Well, the way that gas is calculated in Cosmos WASM is different from the way that gas is calculated in the SDK. And so having these, and that's like sort of fine, right? But unfortunately, the two gas calculation setups, they don't necessarily play well together. And there have been a number of incidents where like kind of the underlying cause was this gas thing. Another good one. Okay, so like Juno got forked into 125 chains once, right? And even though we don't know exactly how that happened, well, we have some idea. Somebody was able to like read system time on every validator. There were 125 validators. Each validator thought that their own system time in Unix nanoseconds, so they were all different. Each validator thought that their own system time was valid, and blocks were committed so that like with 125 different system times, because each validator does have their own system time. And that's what caused like that one really long Juno downtime. But check it out. There is actually a surefire way to fix that. The surefire way to fix that is to define incredibly tightly what contracts can and can't do. And like right now, if we're not enforcing security boundaries, like, okay, so WASM VM is where Cosmos WASM meets the Cosmos SDK, because Cosmos WASM is Rust code that's compiled to WebAssembly. And so it's not native SDK code. So it needs a place, a library where all that Rust stuff, right, is converted over to be able to like easily talk to the SDK. And so I just grabbed the repository for you guys. This is WASM VM, and I would say that this is like Cosmos security hotspot #1 right now, because like if we look at, I closed the pull request because it's really, I feel like I could have poorly described this issue. And this is the thing, like it's really hard to accurately, describe an issue that lives at the places where 5 different software repositories come together, right? But basically this 676 that I just put in here is a really good starting point for like, okay, how do we strictly define what WASM can and can't do? And I probably have to redo it, but I'll send over, I do have a video that actually I can't share that video because I'll make another video. The video goes through, it shows the difference. So this 676 actually is my first working re-implementation of the WASM VM library. What I did is I wrote a proto file that just contains like super, super clear definitions of exactly what the virtual machine can and can't do. So you're basically like typing the VM calls, and then you're removing WASM VM from the chain. What you actually get is a situation where the chain talks to another program called WASM VM. Right now, the chain bakes WASM VM right in, right? But with 676 in, contracts run in their own virtual machine, which, okay, that happens inside the chain too. But the difference is that like you could shut down your virtual machine, but still be running the chain, right? Because they're running actually separately. And this allows you to actually like watch what's going on. So once that PR 676 is in, you can actually watch calls to contracts in the block log as a validator. So like once your node is up, you can see exactly what contracts are doing. And that kind of visibility is also another security enhancement. So like most of these issues that we've had in Cosmos, the first thing that you need to do is actually go through block logs. Okay, now we got to figure out like at what block did we break? And then, there's always that horrific question of like, okay, and what the fuck happened here? Right? And like I've seen it every time where like you go in and you're like, all right, now what? With that PR 676 in place, you would actually be able to see the individual contract calls. Any validator would be able to sort of participate in that stack trace process to try to figure out what the hell happened. And then really in those situations, right, time is very valuable. Like I remember when Juno had a $2 billion market cap and it was dead. And like, guys, that sucked. That was like 20-hour days times, I think, everybody at Notional and everybody at Strangelove. That is a huge amount of work to like suddenly have, right? And it doesn't go away until the chain is back up because you've got to keep it running. So that's another thing that like when we tighten and strictly define our interfaces, we can avoid issues like that system time read because we want to get really strict, like what can a contract do? There are probably more ways to get really strict than like what I've laid out in 676. But what I kind of realized is that in order to get started on being strict, you have to separate the virtual machine from the main chain daemon. And so, yeah.
Thank you, Jakob. Thanks again. I am not sure if anyone else, I actually have one more question, but I'm a little bit concerned about time. Anyone wants to make a question before, otherwise I will shoot my question. So, okay. So, yeah, Jakob, and again, it's a little bit, result of my reflections over the last years and observing different systems and infrastructure. Somehow, I get in love with Cardano as well. And maybe because of Charles, maybe because of, technology that they are using, recently they expressed, I think, some interest on IBC, and and that gave me a little bit of confidence, if you want, because I always thought about Cardano as one of the most conscious team about security and about the quality and the codes. So the interest for IBC made me feel good.
Makes me feel good to hear that, man.
Okay, really cool. Cool to hear that.
That you're reading that exactly correctly. So I share your positive opinion of Cardano. Actually, they had some similar peer-to-peer issues to what Cosmos did. And all I can say is that they fixed theirs much faster. Much faster. It took them like a day or two. Somebody contacted me because the issues were really very similar. And also it was really, really fun. It was a really good time to sort of hear new perspectives on peer-to-peer.
Jakob, one more question came just right now on the chat, and I think the question, if I understood this correctly, is a little bit like kind of final thoughts, because obviously we mentioned a lot of aspects which are quite concerning, and they are related to the security of the chain and the future of Cosmos. So do you still believe in Cosmos? And do you think we can still build resilient systems on Cosmos?
Oh, definitely. I strongly believe in Cosmos, and I strongly believe that we can still build resilient systems on Cosmos. There is an if or a but, though, and this is where it gets a little scary and worrisome. If we choose to continue to ignore these issues, they will come back. Guys, we haven't had another Luna because we don't have another $100 billion chain. That's it. When the stakes are higher, people try much harder to attack. And to give a little perspective on the Luna attack, it was not easy. It's easy to stop a chain, right? It's hard as hell to do what they did. They repeatedly stopped a chain strategically with the goal of breaking its oracle. And also they were successful. Along the way, they also did a whole bunch of liquidations that, it was probably really profitable for the bad guys. And that's not good. You don't want that. You don't want any situation where it's easy for an attacker to profit. So I would say that the but is that I do think we're at a pretty critical time where I'm well aware that people know about issues in the stack. And I think that I'll put it this way. If bad guys did the Luna thing, and if you dig into it deeply enough, you'll find both my research and then there was a group of mathematics researchers recently that did a thing called temporal analysis on the Luna attack, right? And it was so interesting because they looked at very different data points from what I looked at, but they actually came to the same conclusion that no, this thing was attacked. And more interesting, right? So if you really dig into it, right? So I absolutely can't tell you who did it. I have no freaking clue, and I don't really look at like who did it, but I can tell you who didn't do it. It really doesn't look like it was the Luna team. And keep in mind that like that's a scenario you kind of have to consider, right? You have to actually look at like, did the team just do this, right? And I don't know if they did. There's absolutely no sign of it. So I mean, another thing that I've always thought about the Luna situation in particular is that Do Kwon is getting like, look, he fucked up. Of course he fucked up, right? Like, you know, his $100 billion chain blew up. But did his fuck up lead directly to this? I don't really know, you know. And also, if the other issue is that I really don't think that that the chain would have failed at all if it wasn't possible for the attacker to stop it. I think that really that was like their key insight. They knew how to make it stop, so they knew how to defraud the Oracle. And so I just think that we should really begin to look at like each piece of this very carefully, and you know, try and get it fixed up. Yeah.
Okay, I think we are approaching probably the end. Jacob, that was great. Vlad, anything at the end? Anything that we would like to say? Anything you, Jacob, that you want to make sure that is said?
Yes, I want to tell that at first, thank you, Jacob, for being with us. And moreover, if you want, you can, if somebody watching us and want to meet Jacob in the material world, please, you can visit Interchain Summit 2025 in Berlin. It will be in the process of the Berlin Blockchain Week. And it's very huge. It's 96 different events for now, announced from June 7 to June 22. We will have Interchain Summit for the 2 days. It's Friday and Saturday. And Jakob will be speaker and will participate in the different panels, and at first day and as the second day. So the registration is free because this is from community for community event, and all you need just make the registration and visit Berlin. It will be very interesting and nice event, mostly for the people who are deep in Interchain, who are deep in Cosmos. As you can see, a lot of speakers, but we will announce even more speakers these days. And second, at the next Sunday, it's 8th of June, Dr. John from Oak Security will visit us on the Cosmos Voice number 8. And of course, Jacob, you also know John, and you was mentioned him several times in the questions of the security. We will glad to see you also here. And of course, Jacob, if you want to tell something like call to action, or maybe advice, or maybe some message to the future that will be that people who will watch our record will get, please feel free to do it.
Let's make Cosmos the best. I mean, we are already the best like blockchain framework. Okay, now we just got to make it unstoppable. That's my opinion. And if we take care of these relatively small issues, we can make it unstoppable. So let's do it. That's my thought.
Sounds perfect. Thank you.
Ooh, yes.
Thank you all.
This is what we want.
I really, really appreciate it. See you guys.
Bye-bye. See you.
Bye-bye. Thank you very much. Thank you, Greg. Thank you, Jakob. Thank you to all people who was watching, participating, listening, asking questions. You are great. Participation is very important.